How a beetle survives being eaten by a frog and escapes. For just about every animal on this planet, getting eaten is the end of the story. It's game over. The final, non-negotiable conclusion to a life spent trying to survive. But what if, for one tiny beetle, being swallowed whole wasn't the end? What if it was just the beginning of the most gutsy escape plan in the entire animal kingdom? What if this beetle saw the gaping mouth of a frog not as a tomb, but as an entrance to an emergency exit? This is the incredible, and frankly unbelievable, true story of Regimbartia attenuata, a tiny water beetle that has completely redefined the art of survival. When it gets eaten by a frog, it doesn't fight, it doesn't surrender, and it sure as heck doesn't get digested. Instead, it embarks on a journey through the frog's entire digestive system, from the throat, through the stomach, and winding intestines, and right out the back door. The most shocking part? It pulls this off with a success rate of over 90%. So, how is this even possible? How does a creature measuring less than 5 millimeters long turn a predator's gut into its own personal escape tunnel? To really get how genius this beetle's strategy is, you first have to appreciate just how grim the situation is for everybody else. Picture the lush, watery world of a Japanese rice paddy. For a frog, this is an all-you-can-eat buffet. A black-spotted pond frog sits patiently, its eyes locked on the tiny aquatic life swimming all around it. Suddenly, its sticky tongue rockets out and snags an unsuspecting victim, a tiny, dark, dome-shaped beetle. That beetle is Regimbartia attenuata. In a flash, it's pulled into the frog's mouth and swallowed whole. For any other insect, this is checkmate. Frogs don't have teeth to chew, so they rely on a powerful digestive system to do the dirty work. A swallowed creature is headed for a bath in corrosive stomach acids in a dark, oxygen-deprived nightmare. Death is a certainty. From there, its remains would slowly pass through the digestive tract over the next day or more. That's just the rule of the frog and insect world. But Regimbartia attenuata doesn't play by the rules. It has a plan. And that plan kicks into gear the second it enters the darkness. So, how does it survive the initial shock? Getting swallowed is one thing, but surviving the lethal environment of a stomach is a whole other level of difficult. The beetle is immediately plunged into a hostile world designed to break down organic matter. The first threat is suffocation. The frog's gut is an oxygen-free zone. The second is chemical warfare, a bath of potent digestive juices. This is where the beetle's evolutionary toolkit gives it a fighting chance. As an aquatic insect, Regimbartia attenuata is a pro at surviving underwater. It has a brilliant adaptation for low oxygen environments. It basically carries its own personal scuba tank. Before it even gets eaten, it traps a tiny bubble of air under its hardened wing covers, called the elytra. This small pocket of air is just enough to keep it breathing during its perilous journey. But what about the acid? The beetle's second line of defense is its suit of armor. Its exoskeleton is incredibly tough, smooth, and streamlined. This hard, dome-shaped shell acts as a shield, offering crucial protection against the corrosive digestive fluids that would dissolve a softer-bodied insect. It's essentially watertight and acid-resistant, at least for a little while. These are fantastic defensive tools, and they allow the beetle to survive the initial shock of being swallowed. But here's the critical difference. These are passive defenses. They only buy it time. Surviving isn't the same as escaping. Plenty of creatures, like certain snails, can passively survive being eaten and get pooped out, but it's a game of chance with a low success rate. This beetle isn't waiting around. It has a much more proactive and unbelievable plan. This is where the story goes from remarkable to completely mind-blowing. The beetle doesn't just endure the journey, it controls it. This incredible behavior was first documented by Dr. Shinji Sugiura, an ecologist at Kobe University in Japan, who decided to find out what happens when you feed these specific beetles to frogs. He thought maybe the frog would spit the beetle out, since some insects use nasty chemicals to make predators vomit. But what he saw was something no scientist had ever recorded before. Instead of waiting to be slowly passed through the digestive system over 24 hours, the beetles were reappearing out of the frog's rear end, alive and kicking, in an average of about 6 hours. One particularly motivated beetle made the entire trip in just 6 minutes. This speed was the crucial clue. It proved the beetle wasn't just passively waiting, it was actively moving. The beetle literally walks its way to freedom. Using its 6 legs, it starts to crawl. It navigates down the esophagus, pushes through the acidic soup of the stomach, and enters the winding, narrow maze of the small and large intestines. It is on a mission, marching relentlessly toward the only exit. Dr. Sugiura confirmed this with a brilliantly simple experiment. He took some of the beetles and carefully applied a sticky wax to their legs, immobilizing them. Then, he fed them to the frogs. The result? The survival rate plummeted to 0. None of the immobilized beetles made it out alive. They were all digested and excreted more than a day later, just like any other bug. This was the undeniable proof. The beetle's escape is an active, leg-powered cross-country trek through a living labyrinth. It's an incredible story of evolution, and if you're enjoying this deep dive into the weird and wonderful strategies of the natural world, consider subscribing to the channel. We explore amazing stories like this every week, and hitting that subscribe button is the best way to make sure you don't miss the next one. Now, back to the escape. So, our hero has survived the stomach, navigated the intestines, and is now within sight of the finish line. It has reached the end of the large intestine. Freedom is just millimeters away. But there's one last, formidable gatekeeper. The frog's cloacal vent, what you might call the back door. And that door is sealed shut by a powerful sphincter muscle. The beetle is tiny, only about 4 millimeters long. It has no hope of forcing this muscular ring open on its own. So how does it get out? It can't just sit and wait, because every second it spends inside increases the risk of being digested. The scientific hypothesis is as brilliant as it is bizarre. The beetle most likely uses its legs and body to stimulate the frog's hindgut from the inside. It's essentially tickling or irritating the frog's intestine, which triggers a defecation reflex. In a way, the beetle is knocking on the door, politely but very firmly insisting that the frog let it out. The frog is likely compelled to open the vent to expel the irritating presence, and in that moment, the beetle makes its escape. This idea is supported by observations that the beetles are always excreted head first, suggesting they're oriented and ready for the exit they themselves prompted. And then, it happens. The sphincter opens, and the beetle emerges from the darkness, back into the world. Video footage captured by Dr. Sugiura shows the shiny black beetle wiggling out from the frog's vent, looking maybe a little dazed, but very much alive. It scuttles away, seemingly unharmed by its harrowing ordeal. The success of this strategy is what makes it so revolutionary. In Dr. Sugiura's experiments, over 93% of the Regimbartia attenuata beetles successfully escaped the black-spotted pond frog. They showed similarly high success rates against 4 other frog species too. And they weren't just barely surviving. Once free, the beetles were active and lived for months afterward, completely unfazed by their journey through the digestive abyss. This brings us to the ultimate question: why? How did such a specific, and let's be honest, disgusting survival strategy even evolve? The answer lies in the intense evolutionary pressure of the beetle's environment. Regimbartia attenuata shares its rice paddy habitat with a high density of frogs. For a small, slow-moving insect, being eaten isn't a rare accident. It's a constant, daily threat. Over countless generations, this intense pressure selected for a trait that no other known insect has. This beetle developed a defense that works after the predator has already won. It's a post-capture defense, and it is highly specialized. When researchers tested the beetle against a different predator from the same habitat, a catfish, the strategy failed completely. None of the swallowed beetles managed to escape through the fish's much longer digestive tract. This shows that the escape through the rear strategy is a frog-specific adaptation. Interestingly, the beetles did have another trick up their sleeve for the catfish. Many of them were able to irritate the fish's mouth so effectively that the catfish would just spit them back out. This shows how adaptable these insects are. But it solidifies the cloacal escape as their unique anti-frog weapon. Even other closely related water beetles from the same family don't have this ability. When a frog eats them, they just get digested. For now, Regimbartia attenuata is truly one of a kind. The story of Regimbartia attenuata fundamentally changes our understanding of what it means to be prey. The story of Regimbartia attenuata fundamentally changes our understanding of what it means to be prey. It represents the first ever documented case of an animal actively escaping from a predator after being eaten. It's not passive survival, not a lucky break, but a deliberate, action-packed journey. The beetle takes control of its own fate from inside the belly of the beast. It's a tale that feels more like a prison break movie than a biology report. The beetle comes equipped with its own oxygen supply and body armor. It navigates a treacherous, pitch-black labyrinth filled with acid, and when it reaches the final locked door, it figures out how to trick the guard into opening it. It's a powerful reminder that evolution is the ultimate tinkerer, capable of producing solutions that are as bizarre as they are brilliant. In the ruthless game of survival, where most prey are defeated the moment they're caught, one tiny beetle rewrote the rules. It proved that even when you're swallowed whole and all hope seems lost, there can still be a light at the end of the tunnel. You just might have to crawl through hell to get there. Thanks for joining us on this incredible journey. If you want to see more stories about the amazing and bizarre adaptations of the animal kingdom, check out our video on the bombardier beetle, another insect with a truly explosive defense mechanism. Don't forget to like and subscribe, and we'll see you next time.